Okay, this week we're going to be talking about malware code, specifically code that you can see across the network. We're going to look at an actual malware infection and basically show you a pseudo white paper that goes over the Gozi malware, or one of the variations of Gozi, uh, and the different things that it does to local systems networks in contacting its CNC server. The first thing I wanted to talk to you about was the PCAPs available in the Mod 5 lecture. If you download, you'll see mod 5 caps.zip. When you unzip this file, it'll say v3.cap. If you alter this file name to .pcap, you'll be able to open it up in Wireshark. I will try to update that file, but in case there's any issue, you simply only need to rename the file to pcap. For those of you who haven't installed Wireshark, you might as well get to it because you're going to use it throughout the security and forensics track. Wireshark is an extremely important tool. It allows us to do protocol analysis to see how computers are actually conversing. It also allows us to see source code on the wire. So you can download Wireshark from wireshark.org. It's available for OS X, Linux, and Windows, so there's no reason that you shouldn't be able to do this. If you're using Linux, the easiest way might simply be to do a sudo apt-get install Wireshark. On Mac, I would suggest you download it. Don't use the Mac ports version. Last time I used it, it was extremely outdated and didn't come down with half of its configuration files. So you're best to just download it from the website. Same thing goes for Windows. So what I'm going to do is open the file in Wireshark and just give you a basic example for those of you who have never seen Wireshark before. What you're looking at is the Wireshark 2 interface. If you download Wireshark 1, which you have to put some effort into doing, the interface will look different. It won't look horribly different, but it will look different and you might get lost. So the important features here, things that you can compare to. One, during the Hack This Site challenge, you were using ViewSource or you were using network tools to look at the code that was available on a web page. If you capture the network traffic that's going on between your computer and Hack This Site, you could also see that source code in your network capture. Typically, when you're using a browser, you're going to see these conversations go across HTTP, which is, of course, typically uses a TCP protocol. It can use UDP, but TCP is common. For those of you who haven't taken basic networking yet, this is a TCP handshake. See the SYN, SYNACK, and ACK. You can also notice the source and destination. The source is wherever the data is coming from. Destination, of course, is where they're sending it to. We can see this computer at .100 sends information to this external IP, which of course is a server. The server responds back in line 3, responds back to .100. That's the SYN-ACK. And then in packet 4, we see the original computer reaching back out to the server saying, okay, we've agreed on a connection, let's go. Packet 5 is the first GET request that goes out. For those of you who don't totally understand how web browsers work, it's often a misconception that when you go on a web browser and go to a website, you type in their website, that you're somehow kind of physically going to that server and looking at everything on that server. The reality is your computer connects out to that server, and that server provides you with a copy of its web page that you bring back to your computer and then render. This is why sometimes certain images won't be produced, certain code won't act correctly because your computer doesn't have the availability to render it properly. The other option there is that when an image doesn't pop up, maybe someone deleted it on the server, so the web page is now referencing a file that doesn't even exist. This is what was important about server-side includes. Server-side includes happen on the server. The server is generating them and then creating the web page that it will share with all the other computers. So server-side includes are typically more damaging to the server itself because of the information that could be dragged out of the server. They don't typically do anything to your local host because there's no authority to do anything on your local host. Of course, there's different ways to hack that to change some things, but in the basic usage of server-side includes, the largest amount of damage typically is done to the server that's hosting it. So the other thing with Wireshark, if I select this GET request HTTP, I can go to follow, HTTP stream, and it will show me the requests and responses between that server. There's a few things that we can tell right away. For one, the localhost said, ask the server, will you accept gzip or deflate encoding? And it's connecting to myspace.com. Well, my ISPASESES. So someone mistyped. And the server responds with its web page as an availability. It also says, it's not responding with any gzip or deflate, so there's no issue. And so we get the code that we would typically see if we were to view sources on our browser. Now, some of the things that you'll see with malware code is obfuscation. Malware writers, vulnerability writers, they all have two options. One, we can be above the board and as easy to read as possible. This sometimes is done because of speed, or they just simply don't care if they get caught quickly because either they're just aiming for a very specific target, which they know will hit that page right away, or let's see, the other good reason for going above the board like that, it's really speed. I mean, that's all there is to it. The other option is to obfuscate, to try and hide, to make your code either look as normal as possible, or to make it be so complex that no one could read it right from the beginning. They would have to analyze it further. Now, a lot of these code, for those of you who aren't used to looking at the source code on web pages, this might be confusing. This might look malicious. In reality, it's a token number. Looking for some good functions in here without pulling out some of the other stuff. Now, this looks interesting. This could very easily be base64 uprun presence. It's in a comment or a server-side include. But what you'll find is either the code will be heavily obfuscated, or it will look very simple and open, and only if you understand the patterns of what you're seeing will you be able to define what it might be doing. Case in point, a use after free vulnerability often comes in a for loop. It will be typically appending something to an array or list of items over and over and over again, and then start deleting them. The idea is if I throw enough things at this server, it's going to mess up and lose its place and free a pointer that I can then use. So that's our basics of Wireshark. I'll show you this mainly for the lecture piece. One other point I want to make with Wireshark is if you go to File and Export Objects, and in this case HTTP, you can see a list of objects that were downloaded in this traffic conversation. We have a .css, there's a JavaScript, there's a GIF or a GIF, depending on whose side you want to be on how to pronounce that. Ping, which is an image, And Wireshark allows us to extract these items and pull them out onto our desktop. For this reason, I'm not giving you PCAPs that have malware in them, especially executables, because you could actually extract the executables and run them on your system. And some students are just silly enough to click anything they get. So there's a legal liability to the college for that. So what you'll often find with security research firms, AV vendors, is instead of giving out samples, they'll give you a white paper report. And this is what the lab will go around this week. We're looking at a version of the Gozi Trojan. Keeping in mind, this is an older variant, but in all reality, Gozi is still extremely active. There's a number of different families. We often call them campaigns because they use different techniques in them. Gozi is what's known as a DGA malware. It uses a domain generation algorithm. So it basically creates a list of possible website names, and an infected system will go out and look for all the websites on that list until it finds an active CNC server, command and control server, for which to get updates or new information, or maybe other malware to download, different commands. Gozi specifically is a bot, can create a botnet. So what you're going to be doing in this lab is looking through this lab report, this pseudo white paper. It gives you details about who detected, who's writing the paper, what they found while doing the paper, certain identifiers. These could be registry keys, specific names of executables, different hashes, hashes being a calculated sum of all components of a file. Keeping in mind, well, we're not going to go into hash collisions. Some of you already understand that. Some of you, it might be a little bit too far out at the moment. So as you go through this paper, you're going to be explained to you about different possibilities of program download, infection vectors, different samples that could be available for this particular malware, things that you will see in an infected page, or I'm trying to think of the best terms to use, because we use like 5 or 6 different ones. A page that's infected that delivers malware can be called a dock. It can be a delivery station. It can just simply be an infected page. Often what you'll see in an infected page, you have to look for the script tag, because that means it's going to be doing something more active while your browser's there. And then you might see obfuscation. This right here is an example of Unicode obfuscation. If you were to remove the percent signs in between, this is really hexadecimal code. The unescape function actually decodes the Unicode to be a standard lettering format. Now, you also might see transitions, translations, which are, someone decided to do a coded dictionary. So instead of A equaling A, now Z equals A, and it'll have to go through a function that kind of translates all of the code after it comes out of another layer of obfuscation. What I want from this report, I want you to explain to me what you understand and what you don't understand. For those of you who might already have done things like this or are used to white papers, write your summary in the sense that you're telling a parent or a boyfriend or girlfriend, wife, husband, sister, brother, whoever, someone who doesn't understand computers very well. You're trying to explain to them what this malware does if it infected their computer. How do you know it's there? How do you know their computer could be infected? What signs on the system do you see? What kind of signs do you see on the network? What kind of things might you see on the web page? For screenshots this week, when you ask a question about an item, screenshot it. When you're talking about a specific item, like let's say we're looking at the registry keys. There we go. There's some registry keys right there. If you decide to tell me something more about these registry keys, like what exactly it might mean if it was in the run directory, screenshot the registry key, then give me your explanation. This means that we're both looking at the same part of the report, because registry keys might come up more than once in here, and they can mean different things. Same thing with the PCAPs. I mean, if you have a specific question about certain items, screenshot that item in the lab report. I have no expectation that every single one of you has ever even read a white paper before, let alone being able to understand all the different parts of the white paper, because some of them deal with localhost, some of them deal with network traffic, some of them deal with the basic design of a malware botnet. And certain jobs don't require you to understand all of that to begin with. But if you're going to be working in forensics or security research field or incident response, this is information you need to know, and you need to understand how to digest it and get the best information from it. So that's what I expect from your summary. Don't give me just a couple of words saying, oh, wow, the Gozi malware is bad. Or, 4 sentences that just basically state, well, I looked at this part and it was confusing, and this part was really confusing. And I've already gotten a couple of those reports. That's not really doing the work. You're not even attempting to guess at what's happening. For those of you who haven't done that, thank you very much. But what I want you to do is actually read into this information. If you're going to be in any of these fields, or you're already in them, you need to understand how to digest this information. How do I know that I'm infected with Gozi and, not Kersplat, or name your infection? If you have any questions, please reach out to me. You have my phone number in the contacts. Some of you have already found have already contacted me on Google Hangouts. It's great. If I have a moment to jump right in, I'll give you a response as soon as I can. If not, feel free to bump me again if I haven't contacted you back in a couple of hours. If you're contacting me through the school course messages and stuff, I try to check them every night. Sometimes that doesn't happen. And it also doesn't always notify me through my email at work due to the different security devices we have in place. So if you need help and it's really urgent, text me, call me, fire up Google Hangouts and message me, however you want to do it. But don't wait till the last minute and then ask me a bunch of questions Sunday night. I don't always have time to answer you back as much as I would like to. And there's a certain point where I'm not going to kill myself if you're not going to do the work. So try to have a little fun with this. I know it's not as much fun as the Hack This Site challenge. Unfortunately, I just can't give out a bunch of malware samples and say, here, do some static and dynamic analysis. If you move on to other courses here, you will... Antonakis used to have some samples that he sanitized that he used to give out. I'm pretty sure they're still in the courses. Four-year colleges, you will definitely start to see samples, especially if you push into your master's. As always, just ask questions. Remember that we're not in a classroom where all the other students can snicker and make fun of you because you asked something silly to them. That is not my intention with teaching you this course. Everybody has to start somewhere. Some of us start with a little more knowledge than others. There's no stupid questions. I want you to understand how to do this. And if you're confused and you're not asking the questions, I don't know how you're ever going to understand it. Most of us can't simply read hours and hours of web pages and just digest all of it and it instantly makes sense. There are very few people that I know personally who can read a manual and instantly understand how the product works. Most of us have to pick up the product, do something with it, and see how it acts. Malware is often that's the only way to analyze malware. So if you're one of those people who has to mess with it, see what it happens, what if I change this, what if I do this, you're in a perfect field. If you're one of those people who has to read manuals in order to understand a project, you're going to have a little rougher time, but the white papers are what's going to help you in the end. So let me know if you have any questions. Try to have as much fun as you can with this. Don't give me, a 4-sentence summary. If you've got questions, remember to do screenshots. If you're talking about a specific event or infection vector or anything else from this lab report, take a screenshot of it. Make sure that I know what area of the lab report you're looking at, so there's less confusion, because a lot of the terms will be repeated for different sections. So have fun and let me know if you have any troubles.